I'm just very happy that the alarm's not on because unlike my previous speakers, I don't know if I would have been able to last up here. I'm not as good under pressure like that. But today I want to talk about our Linguamatics partnership with ChemAxon. Several of the presentations today, the customer/partner presentations mentioned natural language processing. And they kind of excited us because that's kind of our thing. So before I get into the collaboration, I want to talk about a little bit about Linguamatics. So Linguamatics world headquarters is in Cambridge, UK, and our US office is in Boston. Well, for UK people, anywhere in Massachusetts is Boston. But we're actually in the Marlborough area. But we're an NLP, natural language processing, text mining company that focuses on fact extraction and knowledge synthesis. We're in 17 of the top 20 pharma, and we're in healthcare and government. So we have a lot of good opportunities or good examples of different verticals from healthcare to pharmaceuticals. So what do we want to do? With ChemAxon, we want to be able to answer precise questions. For instance, this substructure. What are inhibitors? So we're not just looking for chemicals, we're looking for how they interact in things like literature and other information. Our databases sometimes have this information, but what we want to do is be able to look at any kind of textual sources. For instance, this is an example we did with the FDA, where they theorized that Stevens-Johnson syndrome should have been added to drug labels. So basically the inserts that you get with a medicine. They believe that Stevens-Johnson syndrome should be added to some of the chemicals that had a benzene ring or a carboxamide group. And depending on the distance, the likelihood that it should have this adverse event. And so we were, with the name to structure ChemAxon tool, we were able to identify a lot of the chemicals that had that substructure, or those two substructures, and whether or not in the adverse events it had Stevens-Johnson syndrome. And so with this work, we were able to have the 3 times number of drugs versus the manual curation in-house tools that the FDA was able to do. And with this project, they actually went back to pharmaceuticals, and requested that they update their labels. I think it was around 400 labels had to be updated with this adverse event. So we want to be able to take advantage of not just being able to text mine, the chemicals, but also being able to text mine and get the context of the information. What I want to talk about now is kind of the document to knowledge. And so I'll talk about different ways that searching can be done and how it relates to value. Normal searching, kind of web searching, is usually done by putting in keywords or terms. And then that brings back a bunch of documents. And then you have to individually look through each one of these documents to determine whether or not this is a document of interest. That's kind of method. It brings back documents, not relevant information. So you have to manually curate to go through all this information. So normal web searching, what we can do is enhance that kind of experience. The first thing we can do is add terminologies. So within Linguamatics, we have things like ontologies that allow us to connect or normalize information like tumor, neoplasm, cancer, and be able to group that kind of information together using a lot of publicly available ontologies. And then also we use natural language processing to look for relationships and sentence co-occurrence, things like that, and even be able to do precise negations. Like, for instance, we're looking for pressure, but not blood pressure. And then, of course, what we're here for is mostly for the chemical structuring. So a little bit about the component we use for the name to structure from ChemAxon. It is basically being able to identify chemical concepts on the fly using smiles or INCHI. And the key part here is that using the name to structure, we're able to capture different types of names into a structure and then allowing it to have consistent naming across the structures so that we can normalize across these names. And this allows us to do some clustering around the properties. So the next kind of value-based is a kind of relationship extraction. So I mentioned this before about kind of searching on web searches, in this case looking for two terms, like etanercept and cyclosporin. Now, you get a bunch of documents back, but in reality, you have to read them to find out that one has its several sentences apart and one is adjacent sentences. So which one is more valuable and what's the ranking in that? And so we help with that kind of information by, instead of needing to read through all the documents, you can have the hits in context. And here's kind of an example. So we're trying to find meaning out of these words. So here we look at nimesulide is a selective COX-2 inhibitor. So with ontologies and ChemAxon, we're able to identify the chemical. And with other ontologies, we're able to identify the gene, the COX-2, and its type of interaction inhibitors. So you see down below that the chemical inhibits an oncogene ID. So we're able to put that, take that information in what's sometimes called a triple store, and you've got A has a relationship to B, and you're able to do things like put that into a data store and have the kind of information based on the natural language. So the next level, assertion clustering. So to be able to cluster information, you need to be able to normalize it. So we've taken ontologies and stuff like things like that, so that you can look at diseases and genes that have been normalized, even dates and measurements. So a good example is the measurements where, say, it's 0.02 grams, 0.2 grams and 200 milligrams. We normalize that to 200 milligrams. So you don't have to do any of that kind of, when you're searching through different literature or different types of documents, it's already normalized. And then, of course, there's things like categorization, where we mentioned denies alcohol and tobacco use and is not a cigarette smoker. Those can be categorized as non-smoker. And then, of course, you've got the relationship mentioned below, where we're using the name to structure. So here's some examples of being able to extract numerical information. And you see we normalize it. So the part of the normalization is so that we can cluster the information. So you see here we've got a chemical, then it's IC50. And also below that, we got some dosages of chemicals all clustered together. So we're able to extract that from the right, as you can see, shows the kind of hits in context. So you're actually able to see the information. So instead of reading all of these papers, you're actually able to read maybe, in this case, I think there's about 12 documents. Instead of reading 12 papers, you're reading 12 sentences. So you can get to the information much quicker. So that thing is profile. So now that you'll be able to normalize and categorize information, now we can do things like profiling. So here's an example. We're looking at cyclosporin, where we can find what it treats. So what kind of adverse event or disease does it treat? What's its dosages that were mentioned? What are its targets? What kind of disease is it related to? And what's the IC50? And we can cluster all that information together, and you can see in the doc column, the fifth column, provides the different types of documents, the different documents that were used. So we'll all be able to get this from all different sources and cluster it together. And so the last thing I wanted to talk about is joining the information. So the greatest value is to be able to link information together. And so a good example would be in patents. In patents, they normally don't name a chemical. Well, they kind of name a chemical, but throughout the document, they don't use that name. So they use like an example 12. And so here's an example where in a patent, they have the example 12, they name it, but later on in the tables, they talk about the example 12 is 8, I think it's IC50. And so we're able to connect that information so that the user who's collecting this information can just have one row of information where it's an EC50 of 8 nanomolars. So it combines the results together. So in conclusion, I want to say that Linguamatics focuses on taking unstructured information and making it structured. So that way you can have actionable information for decisions of support. And if you have any questions about our company or our product, please contact me. We'll be here for a while. And Rick McGuire is here too, so you can talk to any of us around. So thank you very much.